चैप्टर नंबर 3 द वर्ल्ड ऑफ नंबर्स। आज हम डिस्कस करेंगे इरेशनल नंबर्स। सो लेट्स हैव डेफिनेशन ऑफ इरेशनल नंबर्स। A number that cannot be expressed in the form of p by q, where p and q are integers and q is non-zero, is called irrational number. So any number which cannot be expressed in the fraction form or in the form of p by q. Here p and q, this p and q are integers. This is most important. So number that cannot be expressed in the form of p by q, where p and q are integers and q is non-zero, is called irrational number. So is there exist any number which is not an irrational number? Every number we can represent in the form of p by q, but p and q must be integer. That is an important condition. So here we have one question: can root 2 be written as rational number in the form of p by q? No. Why? Even we can write root 2 as root 2 by 1. It is not in the form of p by q because p should be integer, and here what is value of p? Root 2. Root 2 is not integer. So that's why we cannot express root 2 in the form of p by q. So any number which cannot be expressed in the form of p by q is irrational number. Therefore root 2 is irrational. So every number like root 2, root 3, root 5, these are the irrational number. In general, for any prime number p, square root of p is always irrational. I will discuss some important concept. Root p is irrational when p is prime number. Square root of n is also irrational when n is a not perfect square number. We can say that a number which is not a rational number is an irrational number. So we got now two types of number: rational numbers, irrational numbers. Rational number contains integers, natural numbers, whole numbers, and numbers other than these three sets are considered as irrational number. For example, square root 2, square root 3, square root 14. Show that root 2 is irrational number. To prove this statement, we are assuming that root 2 is not irrational number. Then root 2 is rational number, and by definition of rational number, we can express root 2 as p by q, where p and q are integers and q is non-zero. This p by q is in a reduced form. It means what? P and q have no common factor other than 1. So p and q share only 1 as a common factor. It means they have no other common factor than 1. 1 is the only common factor. Taking square on both sides to this equation, what we get? Root 2 square is equal to p by q whole square. Root 2 square is 2 and p by q square means p square upon q square. Now multiplying both sides by q square to this equation. So if I multiply 2 into q square, that is 2 square, p square upon q square multiply by q square, which is equal to p square, because q square will get cancelled. So we got 2q square is equal to p square. We know the general form of an even number. For any integer n, even number can be generalized or can be represented as 2n, where n is any positive integer. Okay, so here also we obtain p square is equal to 2 times q square. As q is integer, so q square has to be integer, which is also positive. So 2q square represents what? Even number. So that's why p square becomes here even number. This shows that p square is an even integer. If the square of a number is even, then the number itself must be even. We know the property square of even number is even. So as p square is even, so p has to be even. So p is even number such that p can be expressed as p is equal to 2k for some integer k. Substitute p is equal to 2k in equation 2q square is equal to p square. That is last equation. Why p is equal to 2k? Because p is even number, and even number can be written in the form of 2k for some integer k. So if I put here value of p in this equation as 2k, I got 2q square is equal to value of p as 2k whole square. This implies 2q square is equal to 4k square, because 2 square is 4 and k square is what? K square. Now dividing on both sides by 2, we get q square is equal to 2k square. Now look here again, q square is equal to 2k square. Since k is integer, okay, after taking its square, it again become integer. So 2k square, this become what? Even number. So q square is even number, and as q square is even integer, so q is also even integer. Now, as p and q are even integer, so they have a common factor as 2, because 2 is the factor of every even number. So p and q are even, so 2 is factor of that p and q. But what we assume? We assume that p and q have no common factor other than 1, which is a contradiction. Here we got p and q has another factor than 1, that is 2, and we assume p and q have no common factor other than 1, which is the contradiction. And why this contradiction arises? Just because of our wrong assumption. What we assume? That root 2 is not irrational. We assume root 2 is a rational number. So our assumption is wrong. Therefore, root 2 is irrational number. Hence proved. With the help of contradiction method, we showed that root 2 is irrational number. First, we assume root 2 is not irrational. Then, by definition of rational number, we express root 2 is equal to p by q in lowest term. Lowest term means p and q have only 1 as a common factor. Then we obtain p square is equal to 2q square. Then we showed that p must be even. Then again after that we showed q must be even. So contradiction arises as 2 becomes a factor of this even number p and q, and our initial assumption become wrong. That's why root 2 has to be irrational.